The best way to learn something is to actually do it. You can read a bunch of textbooks, but if you never really get your hands dirty, you're never gonna understand it. And so for this project, I would like to actually build a robot. I'm gonna start from scratch. I'm gonna buy a remote control car from Amazon. We're gonna look at what's inside of it, and then we're gonna transform it into our own robot. I'm gonna put a Raspberry Pi on it, which is gonna control everything, and then the sky is the limit. We can put different cameras, different sensors, and make it do whatever we want. So let's start building. Alright, so that's the remote control car I found from Amazon. I just picked the cheapest one I could find, and this is really gonna save us a lot of time. I've done videos before where I 3D printed the car, I designed everything from scratch, but at the end of the day, the car was much worse had I just bought it online. And so this one, for example, has a suspension system, it has a differential to make better turns, and we can focus now on the fun parts, which are to actually connect all the hardware and program the car. Alright, so the first thing we need to do is to open the car and see what's inside of it. Usually there's going to be 4 main components in these cars. In this case here we have 2 motors. One is a normal DC brushed motor to move the car. There's a servo motor to steer it. There's a battery, of course, and there's also this device in this red box, which is the combination of a ESC motor driver and a receiver for the remote controller. They're all in this box. But because in this case we're going to use a Raspberry Pi to control everything, we can just get rid of this component. Alright, so for this project we're going to need 4 main components. There's going to be the Raspberry Pi, that's the brain of our project. It's going to run our programs and talk to the different modules. We're also going to need something called a PWM controller. I'm going to explain in detail later how all of this works, how these boards work, but pretty much we're going to use this PCA 9685 module board. It's always complicated to say these names. I don't know where they come from, but I always sound cool when I say them. But this one has 16 channels, which you can connect up to 16 devices to it. The Raspberry Pi actually has 2 channels, but we're going to need more than that, so that's why we're using this module. We're also going to need a motor driver that's going to convert the low power signals from the PWM controller into the actual current to the motor. And for that, we're going to use, again, a complicated name, the BTS7960 motor driver. And finally, a power supply that's able to convert the power from the battery into a stable 5-volt supply that's needed by the Raspberry Pi. To mount all of these components on the RC car, I'm just going to use 2 acrylic boards. I found that sometimes it's easier to just mark some holes on acrylic rather than to design something and 3D print it. So I'm just going to drill some holes and connect everything with bolts. At the end, that's what the assembly looked like. All of the components are now 2 layers because I couldn't fit everything into one acrylic board. Now that we've put all of the modules on the RC car, we can actually connect all of them together. So the first one we're going to take a look at is this PCA 9685 module that is going to be our PWM servo driver. And this one's going to take a VCC and a ground input, that's just to power the board. And also it's going to communicate with the Raspberry Pi over the I2C protocol. That takes 2 pins only. That will be the SDA pin, that stands for data, and the SCL pin, which is the clock. And you're going to match these pins with the ones in the Raspberry Pi for communication. And we're going to have some outputs here. The outputs are going to be the PWM signals. If you don't know what PWM signals are, they are a way to kind of create an analog signal from digital pins. So you're pretty much just turning them on and off so that on average you give a certain amount of analog voltage that you desire. And this kind of PWM signals are used by different devices like motor drivers, like servo motors, and also, for example, to control the brightness of an LED. And then finally, we have these screw terminals here. That's to provide power to the servo motors. We don't want the current to come from the Raspberry Pi. It's really not meant for that, only for the logic. And so we need some sort of external power to actuate all of these servo motors in this case. And that's going to be coming from our power supply, our step-down module. The next module is the motor driver. We're going to be using the BTS7960 driver to control the motor, the direction, as well as the speed that we want it to go. There's going to be 8 pins. We're going to have the VCC pin and the ground. We're going to have these 2 pins to enable our motor driver. We're also going to have these 2 pins that we leave unconnected. That is going to be if you want to monitor the current going through our motor driver. And the 2 most important ones are the PWM pins. There's going to be the right PWM and the left PWM. This is going to allow you to control the motors into different directions, for forwards and backwards. So if you want to control it forwards, you're going to provide PWM to this pin. And if you want to move it backwards, you're also going to provide PWM to this other pin. On the high current side of this board, we're going to have our screw terminal that's going to be receiving the power from the battery and also outputting current to our motor. As I mentioned before, the brain of our project is the Raspberry Pi. That's what's going to be running our code to control everything. But as far as communication, we're only going to connect it to the servo motor driver over the I2C interface. So connecting those SDA and SCL pins to our servo motor driver. And we're also going to need to power our Raspberry Pi over the pins. So we're going to connect our 5 volts to the VCC pin and the ground of the Raspberry Pi. To power everything, we're going to be using a LiPo battery. And just as a disclaimer, LiPo batteries can be dangerous. So this video is only for educational purposes. If you do not have the training, do not use a LiPo battery, and definitely follow all of the guidelines from the manufacturer. But pretty much going to be connecting a LiPo battery to a step-down module. As you can see here, it's going to be taking 2 inputs from the battery and outputting the 5 volt that we need for our circuits. And then we're also going to connect the battery directly to the motor driver module that we used before. That's going to be providing the current to our DC brushed motor. So after putting everything together, I just wanted to check if all the connections were right. So I created a small script just to check if the motors were connected correctly. And then I can turn the wheels and move the car just by using the arrows on my keyboard. The point of this video was to really focus on the hardware, but for the second part, I'm gonna program it properly. But pretty much the Raspberry Pi is connected to my home network and I'm talking to the car from my laptop via WebSockets. So now we turn a dumb RC car into a smart one with the onboard computer. And now it's a clean slate that we can build on top of for future projects. But that's pretty much what I have for this video. If you stayed to the end, thanks very much. You can like and subscribe if you'd like, because I'm gonna make part 2 of this video, which is gonna be to actually program our RC car to do what we want. As of now, I showed you I only did this POC script, this proof of concept that can move it back and forth and then turn the wheels. But let's actually make it in a more professional way. Let's draw everything out, make some architecture for it, and then program everything in Python. Also, you're gonna learn a lot about how to program a robot like this. So see you in the next video, and thank you.